Good afternoon. Good afternoon. Hey, I'll check at the end that you're still awake, if that works. My name's David Aiken. I'm a technical product manager at Microsoft for Windows Azure based in Redmond. Don't let the accent confuse you. I am from the northeast of England originally. I apologize if Geordie isn't your first language. I'll try and be a little bit slower. This is a very demo-heavy session because I thought if we're going to show you how to build your first cloud app, we should probably get in Visual Studio and show you how to build it. So if you were expecting 97 slides in this session, this is the wrong session to be in. We're going to do some demos. The second thing is, it's 5 years ago I actually did the first cloud services demo session at TechEd, and we were in Barcelona that year, so in Spain again. So it's quite fun to be back 5 years later doing almost the same talk. But the tools and the technologies have moved on tremendously since September of 2008. So it's quite fun to be here. So what on earth is a cloud service? I thought I'd start off with that. And then I kind of sat for about a week trying to draw out a whole bunch of slides to explain what a cloud service was. And I thought, why don't I just do a demo instead and show you what a cloud service is? So, hey, we're in demo already. How about that? So I'm going to flip to the demo machine. I'm going to attempt to flip to the demo machine. All the technology I can work at today. This is my desktop, and I'm going to go into Visual Studio, and I'm going to build a cloud service. And as we go through this, I'm going to explain all the pieces as we come across things. So it's going to take a little bit of time to get our first cloud service deployed. Once we have that deployed, we'll come back, and we're going to add a whole bunch of new things to the cloud service, and we'll deploy a second version of it. And then if we have time, we'll come back and we'll do a third rev and deploy a third rev of that. And each time we'll build upon and we'll learn a little bit more. Before I go any further, who in the audience, show of hands, has used Windows Azure before? So quite a few of you. Who have cloud services deployed already? A couple of you. That's good, because if you all put your hand up, the next kind of 70-odd minutes would be kind of boring for you, really. On there. So let's get started. I'm in Visual Studio 2012. I'm going to create a new project. And as part of the templates, what I've done is I've installed the Windows Azure SDK. We have tools for Visual Studio 2012, 2010. We have different versions of the SDK. But I've just went and installed the latest versions of the SDK. And I'm going to select Cloud Service. I'm going to call it Windows Azure 5. For fun. We'll click on OK. And that's going to bring up this dialog box. Now, what we've got to do in a cloud service is a cloud service is essentially an application that's going to run in Windows Azure. There's two parts of this application. One is a part that runs a web front end. And we call this a website or a web application. No surprises. And this lives in a thing called a web role. And I'll explain what roles are as we kind of get through. The other one we're going to do is a worker role. And a worker role is exactly the same as a web role, but it doesn't run any websites. Think of it more like a Windows service. It's going to do some background processing. So you can imagine a kind of end-tier application where you've got a web front end, and you've got some background business logic, some kind of decoupled processing. You can build this kind of architecture within Windows Azure. So I'm going to select a web role, and we're going to call it Cool UI. We'll call it Cool UX, because that's the cool thing now. We'll also add a worker role, and we'll call this background stuff. And then we'll click on OK. We'll come back and add some more things on in a little bit. So what's going to happen now is it's going to create 3 projects for us. It's going to create a web application project, a worker application project, and a special cloud service. And it's the special cloud service that kind of has all the interesting Azure-specific gunk that ties it all together. So let's go and have a look over here. So we've got 3 projects created. Cool UX is just a web application. It has some ASP.NET. It could be MVC. It's whatever you want it to be. There's nothing special. There's nothing Azure special things in there. We also have background stuff, which is a kind of C# app. Think of it like a Windows service. And then we have this Windows Azure 5, which has a couple of files in there. There's service configuration, and we've got 2 of those. One's for cloud and one's for local. And then we've got service definition. And we're going to come back to those files, right? I really want to deploy something quickly because it takes 8 whole minutes to deploy. So if we're going to do 3 deployments, we're going to be waiting 24 minutes to deploy this sucker, right? So we've got to get there quick. So what I'm going to do is I've built my app. Did you blink and miss it? So I figured I could write some code and show you how to write some ASP.NET. But I thought, since it's an Azure talk, I should just focus on the Azure pieces. Okay? If you want to see me write code, come by the booth later, and I'll show you how I write some code, if that's your thing. But let's go into the Azure portal. And here's my brand new subscription. This is what your subscription will look like when you go and activate your MSDN offer and get some free DOS to run on Windows Azure. Okay? You all have MSDN, right? Yes? Cool. Awesome. Hey, great. So you've got between $50 and $150 to spend on Azure. And all the things I'm going to show you will cost you maybe about, I don't know, depending on how slow you are, maybe up to $1 in usage. So this is my Azure portal. What I'm going to do from Visual Studio is I'm going to right-click and I'm going to say Publish. Now, this is kind of like a web deploy publish, but not quite. What we need to do is import in a Windows Azure Publisher profile. So I'm going to click Import. Now, usually I kind of don't have this already configured. Usually I have this all configured, but I thought it would be interesting to kind of show where that comes from. In fact, what I need to do is sign in to download credentials, which makes no sense, even in English. And if I click on OK here, what it does is it takes me to the Azure portal, and Azure will generate me a publisher settings file, and then I can download that file and import it into Visual Studio. So you've got to do that piece first. And it takes a few seconds to generate that file, and usually it's done by now, so I've run out of things to say. Oh, there it is. So we're going to save that in a nice place. We'll call it Demos, and we'll... Oh, we've already got a TechEd folder. We'll overwrite that one. Super duper. So now I can import, and if I go into the TechEd EU folder, click the file that was downloaded, click on Open, what I get is a list of all of the Azure subscriptions that I have access to. Now, I'm in the Azure product team. I have quite a few subscriptions, as you can see on my list. And today I'm going to use DevCon 5. Now, once I've decided which subscription, I need to create a new cloud service. Now, I can do this in the portal, and I'll show you how to do that a little bit later. But here I'm just going to create a new cloud service, and I'm going to call it David Bacon EU. Now, this is actually a public DNS name I'm creating. So it has to be unique. That's why we always think of wacky things to create. And the combination of David Bacon and EU is pretty low down on the list of used domain names. I then get to pick which one of Windows Azure data centers I want to deploy this into. Right now we have, and even if there's not 8 on the list, we have 8 data centers worldwide. We have 4 in the US, 2 in Europe. Did I say 8? God, sometimes. Yeah, 4 in the US, 2 in Europe, and 2 in Asia. And we have a 1 coming online in China, and 2 more as well. My list doesn't have everything because I'm an internal account. I get abused quite a lot by the Azure team. But we're going to go into North Europe with our demo here. So I was going to go ahead and create that. And I can choose, do I want to go in production or staging? We'll get to that a little bit later. Do I want debug or release? Cloud, blah, blah, blah. We'll click on next. Blah, blah, blah. Click on publish. Cool. So what's happening now is it's taking that application that I didn't write, and it's basically creating a zip file. So it's zipping everything up. It also creates a configuration file, which tells Windows Azure exactly what type of application I'm deploying. And remember, we created a web role and a worker role, whatever those are, because we haven't really explained that yet. So this kind of configuration file will say, hey, Windows Azure, there's a web role and there's a worker role. Go and deploy these things into whatever data center we selected. Okay? As that's doing that, we'll see this will update the package. It'll upload it into the Windows Azure portal. And in about 8-ish minutes' time, that'll be finished. So I wanted to get through to that so it can be deploying. And now we'll go back and we'll talk about what on earth really is a web role and all that kind of thing. So I'm going to flip across to the slides on there. And this is called killing time with slides. So cloud service, it's not virtual machines. So you might have come across Windows Azure and you can create virtual machines. This isn't virtual machines. There's a thing in Windows Azure called websites, which allows you to deploy just some website code. It isn't websites either. It's a kind of hybrid. It's a bit of virtual machine and a bit of website. What we're going to do with that web application, that cool UX, is that's a set of HTML pages and ASPX. It needs to run on a machine, on a virtual machine that has IIS installed, right? So what we're going to do when we deploy that app is we're going to build a VM with IIS already installed, and then we're going to copy that application into it and kind of start it. And that's essentially what a web role is. We're providing an OS that has IIS installed, and we basically copy your web application in. That's a web role. We can choose which operating systems and everything we have as well, and I'll show you how to do that in our next run through. The next thing is a worker role. A worker role is exactly the same, but without the IIS bit. So what we do is we create a Windows Server virtual machine, and we copy your code into it, those DLLs that were created, and we basically have a little bootstrap piece of code, and when we start that virtual machine, we'll tell your code to execute. So you don't have to build a VM. You don't have to worry about patching a VM. You don't have to worry about configuring IIS or anything like that. You just go, hey, here's an app. Go and run it. And that's what we're going to do with it. That's kind of cool. Gets you totally out of the OS game. So what's great about cloud services, and I kind of had the question in my head, what do you do with this stuff? Give me an example. You can build almost anything with it. It doesn't have to have a front end that is a website. It could just be back end things. Things like the Harry Potter website, pottermore.com, runs in web and worker roles on Windows Azure. We've done a bunch of work with which we're going to talk about tomorrow and Thursday at Build, so I can't mention the names. But we've done a great amount of work with soccer sponsors around Europe. They're all running on cloud services as well as some of the last year's kind of Olympics kind of scoring and everything running on Windows Azure as well. These are all kind of big things, right? Pottermore, we're doing about 100 million page views a day. So it's a big scale thing. And I know you're all sitting there going, yeah, because I work in a business that has 1 million users per day, right? Cloud services, you can run 1 or 2. You could be running an expenses application that talks back to your back-end SAP system. You could be running a digital marketing campaign for a new car, and that doesn't have any interaction with any back-end systems, is just serving out web content. You could be building a rich media application. So that's the type of thing that you can build, anything in a sense. So what's happening right now is, and it's deploying the virtual machine. I wish we could have two screens up, but no we are. So what's happened is we've built this service package and it's going to be uploaded into Windows Azure, just like that. And once it's in Windows Azure, what we go and do is we go and provision some role instances. Ooh. So we've got web roles, and we've got worker roles, and they're like templates. They're like a class, if you like. They're defining what a role instance should look like, just in the same way as a C# class defines what an object instance looks like. These web and worker roles define the blueprint, if you like. So what we go and do is we go and create actual instances of those virtual machines, which we call role instances. Once we've done that, and that's just part of a bigger pool of machines inside Windows Azure. Once we've done that, we go and deploy the package onto those virtual machines. So if you like, Windows is on the C and the D drive, and we go and put your package into the E drive. That's a good way of thinking about it. It's also how we do it, but it's a good way of thinking about it. Once that's done, we then go and configure a network load balancer in front of it all. So you don't even have to worry about, if you want to run two web servers, two web instances of a web role, we go and put that load balancer in front of it automatically for you. And you don't have to worry about, oh, now I've got to go and find a load balancer and someone who understands how to set those things up. What's also great is we set up a whole bunch of monitoring. So if there's a problem with one of those virtual machines or a piece of hardware that it's running on, we will detect that automatically. And what we'll do is we'll go, oh, the sky's falling in. We'll go and spin up another copy of your role instance, and we'll update the load balancer to point to the new one, and we'll get rid of the old one. So that's kind of cool. And that's just part and parcel. We don't even bother telling you this, because usually by the time we get it fixed, seconds have passed. And we did start off back in, I think, 2008, sending alerts. But by the time you got the alert and you kind of ran to your machine and got logged in, and you looked at the port that said everything was fine, because it was. So then you'd call Microsoft and you'd be like, hey, something's wrong. And we'd look at it and go, no, there's not. And you'd be like, you're lying, and that would all go wrong. So now we stopped sending you the alert. We just fix it automatically for you. So what we should find now is we're deployed. So you can see we've created a website URL called davidbaconeu.cloudapp.net. It is the deployment is complete. So let's go and have a look in the Windows Azure portal, and you can see it's created a couple of things for us on here. First of all, it's created a cloud service called David Bacon EU. It's also created a storage account. And what's happened is when we packaged up those files, it needed to upload them somewhere. So what it did was it created a storage account, and it's uploaded the files into the storage account, which is incredibly convenient because we actually need one for a whole bunch of reasons, as we'll find out shortly. So let's go and click into David Bacon EU. We get this beautiful dashboard on here. This is just HTML5. It runs wonderfully well on just about any device you might own. So whether that's a Windows phone, a Windows tablet, an iPhone, an iPad, something like that, it's all pretty good. We get this great dashboard, and I'm just going to jump the screen. When there's something interesting, I'll zoom in, so don't panic if your kind of eyes are like mine and you can't see anything, right? I'll zoom in on the interesting things, probably. So if we have a look down here, we've got a site URL. We've got a public virtual IP address, so we're 168.63.67.162, that's our IP address. You can see we've also got an endpoint. So on that load balancer, we've had to decide to let traffic in on port 80. If you need traffic in on port 8080, you're going to have to tell us to open that port. As a default, the only one we're going to open is port 80. And the only reason we've opened port 80 is because we told you, we told me to. We told Azure to open port 80. You didn't see that because we didn't dig into the application enough, but that's what's happened. So I can go and hit this site. It just so happened that I wanted to build an introduction to ASP.NET site and run it in the cloud. And that should be what loads in a few seconds once .NET kicks in and cranks up and this network plays well. Ta-da! There's our app. Woo-hoo. I know it's kind of underwhelming, isn't it? Super. So there's our app running. We've got a whole bunch of kind of interesting things around here with a dashboard. We've got some monitoring. We've got configure and scale and instances and all that kind of thing. If I jump into a couple of these things, first of all, instances, you can see I've got basically, if I do this right, nearly right, we've got background stuff. It has I can never remember the keys in this thing. There we are. Background stuff, it's the role, and we've got an instance running of it. And if I just scoot along a little bit, you can see it's in update domain 0 and fault domain 0. What on earth's that? I've also got update, the second kind of instance is also in update domain 0 and fault domain 0. It's like, oh, David, help us. It's confusing. Click on scale. Now, one of the beautiful things about cloud services is because we build the virtual machine and we put your application on it, if you want to have more than one of those running, you just need to tell us how many. As a default, Visual Studio will deploy one of each role, but we can change that in Visual Studio. We can also come along to the portal and go, hey, you know what? I want 7 of these background things, and I'll have 10 of these foreground things, and we'll click on Save. And what's going to happen now is it's going to basically create cookie cutter style more of those worker and web roles. And we're going to end up with a total of 17 of these things running. It's going to take us a few minutes to kind of spin that up. We're also going to update the load balance as we go along. So as we bring more machines on, they'll automatically be connected. This is great. So now we can scale out our application with essentially a HTML5 control. Now, you're all thinking, wow, this is bloody good, right? There's a list of things you've now got to think about, because all of a sudden my app went from running on 1 machine to 2 machines. And I'm behind a load balancer, which is essentially doing a best effort at stickiness, but I tell people, think it does round robin, and then you kind of get the idea. So now we've got to think about where we manage state, how we keep kind of track of users and all that kind of thing. So there's more things for you to think about now. That's great material for the next talk on this. So while that's kind of going through and doing that, let's go back into this project, and we will go and have a look at some of the other things it's created. So back over here, remember we've got our Windows Azure 5 and we've got the 2 roles here. And if I double click, say, on the Cool UX, it brings up the properties dialog for this. Now, first of all, I can set things like the .NET trust level. So I can really lock down my front end and go into partial trust, which is like a low trust setting for .NET. I can also specify how many instances I would like and what size virtual machine to create. Now, in Windows Azure, we have, rather than let you kind of go, right, I'd like a 2-core machine with 8 gig of RAM and some drives, we kind of made these basic shapes that you can choose from. So we have small all the way through to ingeniously called A7. Now, we started off with small. In fact, we have extra small, but that's kind of, you're sharing a CPU. Small is 1 core and 1.7 gig of RAM. Medium is 2 cores and 3.5-ish gig of RAM. There's a pattern, right? Large is 4 cores and 7 point whatever gig of RAM, and it doubles. Then you get on the ACE. So those 4 things, small, medium, large, and extra large, were the original kind of sizes. Then we decided, right, we need a size that has more memory. So we thought, oh, we'll call it the large memory size. But then maybe in a year's time, large memory at being at 28 gigabytes isn't large anymore. So we decided to call it A6. I will tell you now, A means nothing, 6 means nothing. Don't try and puzzle it out in your head. It's just a label, okay? Why is it 6 and 7? Count. That's all I'm saying. So we can pick, let's go for medium this time. We'll deploy 3 of these babies. We can also say, like, hey, you know what, we want to start up and launch a browser and specify endpoints. Then we've got this kind of really interesting thing down here called diagnostics. Now, one of the great things about running an application on a virtual machine that you didn't build in a data center that you don't have access to is knowing what the hell's going on with your application. So this is where having some sort of diagnostics in your application, some sort of logging, is super important. Otherwise, your app's running in the cloud, and the first thing you're going to want to know is, how many instances do I need to run? And you'll go, Dave, how many instances do I need to run? I'll go, show me your performance counters. And you'll go, I haven't got any performance counters. And I go, there you go, get some. So this enables you to turn on all of the diagnostics that you might want to collect. So I'm going to go for a custom plan. I'm going to click on Edit. And I've got a whole bunch of things I can choose from application logs, event logs, perf counters, infrastructure logs, and log directories. I'm going to jump into perf counters and just turn on a couple of perf counters. Okay. If I can actually click on the box, that would be incredibly useful. So let's zoom in. So what I've done now is I've said transfer period of 1 minute, which is probably too quick. A buffer size of 1024 meg, and I've turned on some perf counters, which you should recognize, like percent CPU, that kind of thing. But what's the transfer time? So you've got this virtual machine, and we're collecting some perf counters, and what we're going to do is we're going to store them in a kind of folder on the machine, and we're going to store up to 1024 megabytes in a buffer on that machine. And every 1 minute, we're going to transfer that into Windows Azure storage. And we're going to create a table, and we're going to write out all the performance counters into a table in Windows Azure storage. We'll do that every minute. Each instance will do this every minute. I can tell you that if you have 100 instances and you do them every minute, storage gets a little bit busy. So sometimes you want to slow things down, particularly the sample rates. Devs love sample rates of 1 second, and they're like, 1 second's an eternity. Can I do I want 200 readings a second? And I'm like, no, right? Well, actually, part of me says yes, because that uses way more storage. It costs you way more money. My kids go to better school. But in real life, you want to slow this down. So I'm going to say, I'm going to go as far as 30 seconds. Usually, I would suggest a sample rate of 5 minutes is perfectly fine for a production system. You're not really after spikes. You're after averages over time, right? You can't react fast enough to a spike anyway. So we'll click on OK. There's other stuff we could turn on, but I wanted to show you, like, hey, you know what? You've got to collect this stuff. So we'll click on OK. We'll drop a save on us. Next thing, I've got a whole bunch of settings here. So there's another great thing. Where would I store a database connection string for a web application? You all shout web.config. Yeah? Web.config makes sense? Yeah, one person makes sense too. Good. I'll talk to you now. So web.config is a great place to keep that, but what if I've got 5 instances and I want to update that connection string? Do I have to kind of go and copy a new web.config onto all 5 things? Well, I could do that, but it's a complete pain. So what we've got instead is we've made a separate configuration that is accessible by all of the instances. And what I can do now is I can define connection strings there and use a slightly different method called the read in the connection string. What's great is when I change the connection string, I'll get a notification into all of those roles to say, hey, there's been a configuration change. And I can actually write some code to handle configuration changes. So we're going to take a little detour. We're going to dig into this background process and just have a look at some of the things what we've got here. So this is my worker role.cs. it inherits from role entry point, which is a class we provide. And we have a few methods that you have to implement. One is called run, and we give you a skeleton if you use the template. And look what we do, while true, sleep. Now, what's really important is, if run ever exits, game over. We think you've messed up, and we'll actually go and restart your role. So you don't ever want to exit from there. So while true is a perfectly great piece of code to have in the middle there. We also have a method for starting. This is going to run exactly once when we start up the role. You could do a whole bunch of things in here, like set up connections and all that kind of thing as well. We also have some events that you can intercept, such as configuration changes and that kind of thing. And sometimes you want to build an application that can react to configuration changes. Sometimes you don't want to react to configuration changes. The default behavior is to restart the application. So think of it like we restart the app pool. We don't quite do that, but think of it that way. You can intercept that, and you can change your mind on what you want to do there. Okay? That's a little bit of an advanced topic, and I kind of went there by accident. I apologize on that. I suddenly realized, like, oh my God. So basically, we can add a connection string in here. We can edit it. Then we've got endpoints, and you can see right here we've got that one endpoint. And I said earlier that Windows Azure created that port 80 because we told it to, and there it is. So we could go and add another endpoint if we needed to have another port open. We can give the endpoint a name. We can specify whether it's an external input or just an instance input. So sometimes you want to open up an internal port on that virtual machine that's not accessible from the outside world, because maybe your web role needs to talk to a port on the worker role. You can specify the protocol, and we support UDP, HTTPS, TCP, that kind of thing. And then the port, private port, optional. And then you can also bind an SSL certificate to it as well on there. And that's what that might look like. I'm not going to add another endpoint, so I'm going to remove it. Certificates. I'm going to jump over some things, right? And it's just because we have 75 minutes rather than any kind of hidden devious reason on there. But for certificates, if I need to support SSL, I can upload my certificate. If I need to decrypt connection strings or decrypt data, I can also pop in a certificate here. And what we do is we deploy that certificate and we put it into Windows Certificate Store in a secure way. So you don't have to kind of go, right, I need my cert on the disk and read my cert in. We'll actually go and put it into the certificate store on that web or worker role for you. And then you can read that out and everything. That's pretty cool. And then we'll come back to caching a little bit later. So we've made a few configuration changes on this. In particular, we turned on the diagnostics like that. Now, what I'm going to do this time around, and by the way, we've got worker role. In the web app, we've also got a web role. It has an on-start as well. It doesn't have a run method implemented because it's a website, so we're going to rely on IIS to kind of handle the requests for us. So let's jump in here. We're going to publish again, but this time we're not going to go into production. We're going to go into staging, whatever that is. So I need to jump back to previous. I'm going to select the staging environment, click on next, click on publish, and fingers crossed that will deploy and everything will be good. Again, 8 minutes, we've got to fill some time in. Fortunately, we've got the opportunity to... I'm moving the slides along because it actually tells me which demo I should be doing next on there. So while that's deploying, let's go back in here and we'll have a look at a few more kind of things as we're waiting for that to deploy. So we've got this dashboard. It's going to show some metrics there. Now, it has some metrics now. We've left it running for a few minutes. People kind of go, David, why is there a gap there? Now, remember I said those diagnostics get collected, and then every minute they transfer? Well, there's several timings involved in getting the diagnostics out and then rendering it on the screen. So there's always a kind of bit of a lag. It's not up to the minute. It can be a few minutes kind of behind. And the default settings, it can be kind of like 15 minutes out. in some cases. The other cool thing we've got, and this is in preview right now, is around here. We've got web endpoint monitoring. So what we can do is basically configure some outside-in monitoring where we'll ping essentially your website. You give us a URL. We'll expect a 200 response code. If we don't get a 200 response code after a couple of times, we'll flag it as bad, and you'll be able to see that and get some statistics on it. Under configure, we've got a whole bunch of things to do with configuring those diagnostics that we've just set up. So we've got retention in days. We've got the diagnostics connection strings. Ooh, I never set those. Do you remember? Back in Visual Studio, if I go into the properties for this, and you see where it says specify the storage account, I never said anything there. It's blank. But I do have this update development storage connection strings for diagnostics and caching with the Windows Azure storage account credentials when publishing to Windows Azure. So what's happened is when I hit publish, that storage account it created, it's automatically wired up all of my diagnostic settings so it will go into that storage account. If we want to see the storage account, what we can do is bring up Server Explorer in Visual Studio, and if we just hit refresh on here, and add a new storage account, we can pick now from our subscription, so DevCon 5, it will then go and connect up to the Windows Azure API. Ooh, there's an API. Everything I'm showing you can do with PowerShell or Node.js command line tools. So you can really automate everything. So I'm going to select the David Bacon EU is the account name. Love the Jubilee. We'll click on OK. And what I can do is expand that storage, and we'll have a look, and there'll be a table. And this is the event logs. So what's happened there is we've connected up to Azure Storage. It's connected to a table. Now, when I say table, everyone says, oh, table, it's like a SQL table, right? No. Couldn't be further from the truth. This is like no SQL kind of table. It has... you can have up to, I think, 256 kind of properties in it. There's only two that we care about. There's a partition key and a row key. And together we use those to uniquely identify a row in the table. And that's it. You can't create any secondary indexes. You can't do any group by, sort orders, or anything like that. There's only those two columns. But if you're dealing with an absolute colossal amount of data, and you can work within those kind of parameters, table storage is absolutely brilliant for that. We use it for diagnostics because we have a lot of volume, and typically queries, partition key-wise, we actually use an encoding of the date and time. So if you know a date range you want to read from, you can work out the logic and kind of find the data you need. But here's our event kind of information. You can see it's got things like which role and which role instance. And you can see, see if I get this right. Hey, there we are. Cool UX role has at least two instances running now because instance 1 and instance 4 both wrote something to the event log. So you get in one place to see all of this kind of great diagnostics information. Now, things like System Center can pull all of that data out and actually do something useful with it. As a default, the only thing we give you is the information that will display in the dashboard in the portal. There are a lot of third-party tools that can render the UI, a nice UI, graph out the performance counters and that kind of thing as well. If I scroll down a little bit, you can see we didn't set up any settings, so none's configurable. But here, this is interesting, operating system family. I never told Windows Azure what type of OS to create. We just default to Server 2012. This is stock Server 2012. We didn't muck around with it. We also said operating system version automatic. So you've heard of this thing called Patch Tuesday, right? Yeah? Yes? So rather than and it's a pain, right? An IT administrator's got to figure out, like, can I take the app down? Can I patch it live? All that kind of thing. We've got a really unique way of handling Patch Tuesday. We don't. That's to say we don't patch anything running. What we do is replace the whole OS. So on Patch Tuesday, we'll build a new version of the OS with the right patches and security fixes and wherever else. And then we'll go and replace the one that's running your app with the new one. And it's called a reboot. So at some point, we're going to reboot your app to put this new one on. Now, you might be like, oh, what if the service pack or something breaks me? Well, there's a great thing you can do is you can turn off automatic, and then you can pick a particular version. So I'll go for OS 3.2 release, like that. So again, we're not giving you kind of a list of patches that you apply. Every time we build one of these, we just give it a version, and you can choose. So when a new one comes out, what you could do is deploy your app to another subscription in Azure on the new version of the VM, do all your testing, make sure it's working, and then when you're good, you just come back here and change that value. And that's all you have to tell us. You just drop the list down, change it, click on save, and we go and walk through and update everything. Now, how do we do that? Well, back on instances, remember, that's okay. Back on instances, remember we had this fault update domain kind of palaver here. In fact, let's just do something like that. You can see background stuff is running. We've got 7 instances of that. Is that right? Yep. 0 through 6. And we're in fault domain. This is what we're looking at. So what we've done is we've deployed this onto 7 virtual machines within Windows Azure. But we didn't put them all on the same rack, because what might happen is the power to the whole rack might go, or the network switch to the rack might go. So what we do is we like to spread you out across different domains. In fact, I'm talking about fault domains, so I should have highlighted the other column. The plot, quite simply, is if we spread you out enough, any failure in the data center won't take all of your application down. It'll take some of it down. We get hard disk failures like everyone else. But by putting you in separate fault and update domains, in fact, fault domains, any kind of single incident won't take your whole app down. I realize now I've just confused the hell out of you, because I've just confused the hell out of me on that. We'll try this again with the right column highlighted. It just suddenly struck me. So what we've done, we've got fault domain 0, fault domain 1. Half the instances are on one rack, half the instances are on another rack. We can lose a rack and your app's still running. If we lose a rack, remember, we just go and redeploy it somewhere else and rewire the load balancer, and all is good. Update domains. At some point, we have to go and update that OS. So rather than taking your whole application down, what we do is we update your application one update domain at a time. So we'll take update domain 0, and we'll go and basically restart those machines there. Such a plank. So you can see we've got update domain 0, 1, 2, 3, 4, and then we're back to 0 and then 1 again. So we've got 5 update domains. So in order to get the new OS on here, we're going to do it in 5 different chunks. The first time we'll take down instance 0 and instance 5. The next one we'll take down instance 1 and instance 6, and then we'll take down 2, 3, 4, and 5, 2, 3, 4, sorry, on its own. And that's how we'll do it. This way we can keep your app running while we're doing operating system upgrades. This applies to also the hypervisor. If we have to update the host OS, we can also do that in a way where we're not taking you all down at the same time as well. It's kind of cool. So let's see if our application's deployed yet. It has. Oh, no, it hasn't. Oh, we've got an error. So here's a fun thing, and you're going to hit this all the time. When I scaled up to 17 cores, something happened. When I tried to deploy my new deployment, I ran out of cores, essentially. Unfortunately, we don't tell you this until right at the end when we try and deploy the thing there. So that's terribly useful, isn't it, on there. So I'm going to skip a deployment. I'm not going to try it again. We haven't got another 8-minute slot to kind of waste on that. But what I'm going to do is I'm going to get rid of all the extra instances that I deployed here. I wasn't fast enough talking through this. So I'm going to go drop those back down to 1 each on there. Click on Save, and we'll be good. Cool. Quick flip into slide on that. So we've got this basic framework where you've got web and worker roles. We can write some code. We can deploy it. We look after the OS. We'll patch it and upgrade it. We'll do it in a way that doesn't take it down. We manage the load balancer. We give you all this funky connection thing. You can manage settings, and we give you a way to put diagnostics into storage where you can get at it. We also give you a whole bunch of what we call application building blocks. So you can build an application that uses, say, caching or databases or hook into identity. So a lot of the Windows Azure services aren't designed to be kind of consumed directly by a user. They're going to be consumed by an application, such as a cloud service. And that cloud service can create databases and do whatever it likes. All of these things here are self-service. So you don't need to go and spin. Let's say you wanted a database. You can create a SQL database, and you don't have to create a server. You don't have to spin up a VM, install SQL Server, configure it, put the right service packs on, open up all the right ports. You just come to the Azure portal and say, give me a database. In the same way as we kind of created an application, we'll do it in the same way. We will, behind the scenes, spin up a virtual SQL Server and give you access to a database. The same for things like identity and media services. We spin up these resources, but we're hiding the infrastructure from you, so you can just get on and focus on building your application. So I thought it'd be good if we added one of these services to our application. And then I remembered I wasn't writing any code today. So what I thought we'd do is go and add the cache. So let's talk about cache. Cache is probably used by almost every application I've ever touched, ever. And we're using it both to improve performance, but also to protect resources that have limitations or kind of, you can't put like 100 million users through a single SQL server, right? You might want to put some cache in between there. So we use cache in a number of ways. We have a cache service, but we also have a cache role that we can add into our application. Now, the cache that we have is now wire compatible with memcached, which opens up kind of the protocols and everything that you can use on there. Now, where's my clicker gone? So, we've already got these roles. One thing we could do is use the spare memory in these roles as the cache. So we've got that web role. We could say, hey, you know what? What I want to do is use a bit of that memory for the cache. And we can do that and specify like, hey, from each of the 4 instances here, we're going to use 300 meg. And that gives us a total cache size of 1.2 gig. I'm pleased it said. And it's a distributed cache. We have high availability options as well, so you can make sure that your data is written into multiple places. The other thing we can do is create a dedicated cache. And a dedicated cache is just that. We go and create a worker role, and we say the only thing we want to do in the worker role is run the cache. This is when you need a big, huge cache. So here we've got 12 gig on each role being used to give us a total cache of 24 gig. You might want to kind of use, on the diagram we've got 2 big roles. You might want to use smaller roles, and that improves your kind of availability. Here, if we had an accident and we lost one of those roles, half of our cache would disappear. If we created 12 2 gig ones, the price would be the same. Oh, wow. Because our pricing just basically doubles in this as the cores increase. So if we kind of said, like, create 12 2 gig, it'd be the same cost to run. But if I lose one of those VMs, I only lose like 1/12 of my cache, which is probably much easier to stomach in the big scheme of things. What's great about this as well is back in that poll, remember when we slid the slider up? We can also slide the slider up. So if we wanted a bigger cache, we could just drag the thing along, click on save, and we'll add 2 new cache roles, and all of a sudden we'll have 48 gigs worth of cache. Again, we can slide that cache thing back down. So let's go and have a look at how we add the cache to it. This is going to blow your mind. It's not really. You're going to be underwhelmed as usual. So let's go into our UI again, and on the caching tab, and just clear up the windows a little bit so when I zoom in we can see the whole thing. So I'm going to tick the box that says enable caching. You're welcome. Ta-da. That's it. I can add name caches and specify high availability and all that kind of fun stuff as well. I don't even have to worry about the connection string there, which says use development storage, which is, it says true. Because as we already saw, we're going to replace that with a real connection string when this thing gets deployed. Incidentally, it says use development store. What on earth is that? We feel that you can't just keep deploying to the cloud every time and have this 8-minute round trip. So there's 2 things that we did. One is you can actually enable web deploy within a web role. And it's great. It only works if you've got 1 instance though. But you can do this rapid kind of cycle. It takes you a few seconds. Similar to what Mark showed this morning, but running in a cloud service. The other thing we can do is hit F5. And one of 2 things will happen here. Either I'll get an exception or it'll run. And it really depends on how it's feeling. And it looks like it's going to run, so we'll flip into this. So this is my compute emulator. And locally, what I can do is simulate the cloud. Now, this isn't a parity kind of thing with the cloud. It's not going to run in the same way. For starters, it's going to be faster when it communicates. Why? Because it's running in the same darn process. Right? So all your inter-process communication is going to be like laser quick. There's no network latency to deal with or anything like that. It's awesome. We can go and dig in and view the consoles for these applications and get kind of like traces through, and you see messages and all of the Windows Azure things we're doing, like saying, are you still alive? We have this health message that we send to all the roles. And you can actually write an event handler for that and say, no, I'm not. And when you say, no, you're not, we can reboot you because of that. You can also say, can you reboot me? And we'll reboot you as well. So there's a way to interact with Windows Azure as well. But this is great for doing kind of some debugging locally. It's not great for scale testing. It's not great for integration testing. But if you're trying to debug some awkward .NET code, it's a great thing to kind of go and do. And this just installs as part of the SDK there. And when I stop running this, if I wrote some code, we could have hit a breakpoint. But when I stop running this, you'll see it all kind of gracefully shut down like that on there. Now, so that was our little side trip on what that meant. So as well as having storage in the cloud, and I've got this local compute emulator, I also have a local storage emulator. And again, it doesn't have parity 100% with what's in the cloud. It's for quick and dirty debugging, prototyping, that kind of thing. Usually, even if I'm debugging locally with compute, I'm still going to use the cloud storage so that I get parity in terms of API. Okay? Super. So, where are we? Slides. Our clock says 23 minutes, so I'm doing really good because we're going to have time for that third piece of deployment. David, you're talking about cloud services and you've got a slide that says virtual machines. What's going on? Get out, right? One of the great things that we did with Azure over the last year was give the ability just to create virtual machines. And you can put anything you like in the virtual machine. So it's like having Hyper-V on your dev box, but having it in Windows Azure. And having essentially unlimited capacity to go and create as many VMs as you want. Now this is particularly interesting because if I'm building an application and I'm using web and worker roles, sometimes I have this bit of code that just doesn't fit into that web or worker role model. It might be Oracle, I don't know, it might be some Java, it might be SQL Server, it might be BizTalk or something like that. Getting that in a worker role is pretty darn hard. People have done it though. This is a little bit scary, but people have done it. But having a VM that you can spin up is particularly interesting because now what I could do is have my web role talk to a SQL Server on a VM. That maybe is running analysis services or some feature that we don't support in the native SQL database. So what I want to do in this last bit, as well as do our final deployment, I want to show you how you can hook up both the cloud service and the VM world together. It's a kind of combination of evil, and what spawns from it is pretty fantastic. I love my slides, the great demo. What shall I do there? Oh, I'll do a demo. So I'm going to jump into the portal, and there's a couple of things I want to do on this. First of all, so under virtual machines, I've got no virtual machines. And what I'm going to do is I'm going to create a SQL Server for my application. And I'm going to show you, I'm going to save you an immense amount of time, even if you just want to create a VM, by showing this piece. The first thing I'm going to do is create a network. Okay. Every single installation of anything you've ever done, whether it's been moving into a new office or a new house or a new data center, the first thing you didn't do was set up a server and then go, right, network, where's that go? Right? You always kind of went in, and I moved home in December, and the first thing I did before everybody was unpacking was getting the router out and wiring up the network. It's the same in Azure. So I'm going to create a virtual network. So I go to networks, I create a virtual network. Let's just zoom in a little bit. Give it a name. So BaconNet 343. I also have to create a thing called an affinity group. Usually when you go in, this will be empty, so I'm going to show you it like you will see it. Going to North Europe again. An affinity group, remember a fault domain tried to keep all of your stuff on different machines so that any one machine didn't take your whole app down. An affinity group tries to keep everything together. And that way we deal with latency and that kind of thing in a better way. So we try and keep your app together. So what we're doing is we're saying, hey, I want to create a network as part of the same affinity group. So I'm going to call this Bacon AG for affinity group. Then I get into all sorts of hot water with networking. Now, I'm a dev. I don't understand all the networking stuff. So I'm going to show you what our brilliant portal team have done with this. One thing I might want to do is connect from my machine up to the network in Windows Azure. So I'm going to create a point-to-site VPN connection. If my IT administrator was doing this, they would understand what all of the rest of the things were, right? They get that subnet thing, and they'd create probably a site-to-site VPN connection. Don't get me wrong, I can talk you through that, but it would bore the hell out of you, especially if Visual Studio is where you live. I'm going to click Next, and when I get to here, I'm going to click Add a Gateway, and then I'm going to click Tick. That's how I want you to approach this when you're trying it out. Anything else, and you're just causing yourself a whole bunch of pain. Now, if you do understand subnets and all that kind of thing, go ahead, create multiple subnets, define the IP address ranges, create the site-to-site VPNs and all that kind of fun thing. Go for it. But I figure most of you are devs in this room, and you want to create that network, and you're like, oh my God, do I have to talk to that IT guy? No, just next, and it works great. So that's going to create, take a few seconds, it's created. Now I'm going to create a virtual machine. And I'm going to create one from the gallery. Now we have in the gallery all of these machine images that we've pre-created. We've got Windows Server, we've got Windows Server R2 Preview. So if you want to get that, don't mess on, you all got MSDN subscriptions, right? Go and activate your MSDN benefit. Go and use your $50, $100, or $150. Go and create an R2 preview in Windows Azure. it'll take you a good minute. And while everyone else is downloading the bits and screwing up your Wi-Fi, you can be playing around with the new bits and everything, and it's awesome. So go and try that. Anyway, back to the demo. We're going to create a SQL server running on some version of Windows Server 2012. Why not? Because I'm an MSDN subscriber, I'm going to pay 6 cents per hour for a small instance of this. And most of the time for dev, I can get away with a small instance for SQL. I need to give this a name, so I'm going to call it Bacon SQL. I need to give it a username for the administrator account. And a strong password. These machines have a DNS name on the internet. So if you give it a weak password, like our demo passwords used to be pass@word1, right? And then they all got hacked. So don't do that. That's why I've typed something hard and didn't talk at the same time. DNS name, Bacon SQL. Of course, the other thing I can do is I can close off, because I'm going to be part of the same virtual network, and I've got that point-to-site connection, I can actually shut down all of the internet access from this. I need to specify that I'm going to be in the virtual network. That subnet apparently got created when I clicked next through that whole wizard thing. That will do me. We'll create a storage account as part of this. No, we won't. That takes too long. We'll do that one. We won't talk about the availability sets. And we'll go, cool. So what's going to happen now is we're going to take essentially this SQL server image, and what we've done is we've sysprepped it. So when we start it up, it goes through its little kind of unsysprepping stage, gets a machine name, we put the administrator account or whatever I set it as, and then it spins up. It takes a few minutes to kind of happen, around about 6 minutes actually, and then I'll be able to RDP into it and finish configuring it. We'll pretend it's running. It will be by the time we get through this. The next thing I want to do is deploy my cloud service and be able to talk to that SQL server. Now, in order to do that, I've got to tell my cloud service to deploy into the same network that my SQL server is being deployed into. And how I do this is a little bit more complicated than how I did the cache, right? So what I'm going to do is just load up OneNote, because I never remember what this looks like, so I just cut and paste it in on there. And I'll go into my application, and I'm just going to close all the documents. I'm going to go into one of these configuration files, and every time I've gone into those settings dialog boxes, it's been rewriting these configuration files, okay? So what I'm going to do is just paste this bit snippet in at the bottom, like so, and then we'll talk about it. So first of all, it says, hey, I'm going to define a network configuration. I've got a virtual site name, and the virtual site name we called it was BaconNet 343. And then we need to tell it which instances are going to be deployed in this. So we're going to take CoolUX and put that in there. And the subnet is the same. And basically what I'm going to do is take that, because we've got 2 roles now, and paste in background stuff as well. Cool. So basically what I'm doing is I'm saying, like, hey, look, here's some network configuration, BaconNet 343. I would like you to deploy these roles into a particular subnet. Again, your networking guy is going to go and define all subnets, and it'll be all really weird and strange, and you'll just paste in whatever he tells you into this file here. In fact, even better, remember I said we create a zip file and a config file? This is the config file. So he'll be able to edit that even without telling you. So that's even better, because then we don't see it. The next thing I'm going to do is we can't use this cloud service that we created earlier, because it's not in that network. So I'm going to create a new cloud service in the portal. I'm going to say cloud service custom create, and I'm going to call this Bacon 343 v2. And I'm going to select my Bacon AG from the list and click on OK. So now I'm getting a new cloud service created, but nothing's deployed yet because I haven't told anything to deploy on that. So now we can right-click Publish. If we go back, what we can do is, once that finishes loading, We'll get the Bacon V2. We'll go into production there. And fingers crossed. That was the old one that failed. It's just doing a build. Now, for the smarty pantsers amongst you, you'll notice that we keep getting this kind of warning symbol. As a default, the web application has a default connection string defined to go to a local SQL server to manage state. Because I couldn't care less about the code, I haven't changed that, and that's why I'm getting that warning. You can tell Visual Studio to treat that warning as an error, and it will block you from deploying, which is kind of cool in a production, if they were really writing code, you would probably want to set that up there. So that's going to take about 8 minutes to kind of deploy. Once it does, we would be able to access that virtual machine by basically creating a connection string that points to the internal IP address, which is 10.0.1.4. So that would be our connection string. Unless we start messing on with DNS and putting domain controllers here, there, and everywhere, we're going to use the IP address as our connection string on there. Interestingly enough, you can also set up a SQL Always On cluster in Windows Azure as well and have high availability on your SQL database. Remember that bit where we're upgrading stuff? Even though I've created this VM and I'm in total control of everything in that virtual machine, including patching it, I still have no say in when we patch the underlying hypervisor. So again, Patch Tuesday, we're going to reboot you because we've had to patch something underneath you. And if you've only got one SQL server running, you're going to have downtime. I'll guarantee that. So that's why there's some guidance coming out around running SQL in Always On and that kind of thing. We're going to jump onto here and we're going to dig into the network. What we'll see as this package deploys, and it's uploading, so still. As this package deploys, we'll get a list of the instances appearing as they come through there. Now, last thing on the network, you see this gateway is in red. We just need to click Create Gateway, click on Yes, and that will go ahead and create the gateway resource for you there. Once that's created, we can upload a certificate, which allows us then to connect with our VPN. Again, there's some guidance on the make cert command that you have to run to generate the certificates and where to upload them. Just follow the guidance in the Windows Azure portal for that. So, I think we're good. 10 minutes left. So hopefully that's going to deploy, and we'll have a chance just before the end to jump in and see it all part of the same network on there. So, wow. That was kind of a little bit intense. Azure's always great to show people Windows Azure. It's really easy to get started and deploying virtual machines or building cloud services within a few minutes. I did it all from scratch. There was nothing up my sleeve. Everything was from a file new kind of dialog box. Yes, I didn't write any code, but I didn't need to. I wasn't showing you how to write .NET code. I was showing you the kind of constructs. Hopefully what you've got from this is some idea of like, hey, we've got web and worker roles, and my code gets put into them and I don't have to worry about the OS. So I'm really able to focus on building my applications and less worried about building out my infrastructure. There's a lot of deployment and operations things that are just taken care of. You don't have to worry about creating load balancers and configuring networks and all that kind of thing, unless you want to do that evil thing where we combined the cloud service with the virtual machine. So really, we talk about focusing on apps and not infrastructure as part of cloud services. And this really is the developer's world of I can build and deploy and be very, very happy without worrying about virtual machines. Another great thing, and one thing I didn't show you, and you'll get a kick from this, is we can also integrate this with TFS. So if you're building a cloud application, you've got TFS, we can actually have it so that when you check in, we'll do a build in TFS and we'll go and deploy it into Windows Azure for you. So we can create that full kind of ALM lifecycle on that. Now, I am going to have a few minutes for questions, and then for those that hang around, we'll jump back into the portal in a second. But I do want to go back to the MSDN offer. If you have MSDN and you haven't activated your Azure, it's like you're losing money every month. Every month we're giving you free stuff in Windows Azure, and you just need to activate and take advantage of it. If you're building apps that are not going anywhere near the cloud, you can spin up VMs like Mark showed you in the keynote and deploy apps into them and do testing, and then deploy the production app on premises. Even better, you can build a cloud app, and perhaps you'll build a cloud service using web and worker rules and go and deploy that and do your dev test cycle. And typically, when you stop stuff, the meter stops. You won't be paying for these things unless you're actually actively working on them. Also, you get a chance to win a car, quite frankly. And I, in my head, my Jordiness is going, win a car. It's an Aston Martin car, a V8 Vantage. We also pay the sales tax on it. So it's not like, here's a car, and then the taxman goes, hey, give me like 100 grand for the tax. So we take care of that for you. So it's worth it even doing it just to kind of enter into the sweepstake on there. There's a couple of resources and things like that, but while that's kind of doing, I'm going to flip back to the demo machine, because stuff's starting to happen. Look, here's our network. The gateway is still being created. It takes about 15 minutes to go and create that gateway. But look, we've already got some cloud stuff being deployed, and we've got the internal IP addresses showing up. So these are all part of the same network. They'll all be able to talk to each other. There's one gotcha with this. If you blindly click through next, you might end up with a subnet range that doesn't have enough IP addresses in for the number of instances that you want to run. So when you do this for real in production, go and talk to your nice network people, and they will help you get the right subnets and things defined on there. Cool. So with that, I hope I've given you a great kind of taster of some of the things you can do and some of the things to look for, particularly diagnostics. I kid you not, in a former job at Microsoft, there was 2 reasons why you saw me. One was because you came to TechEd or something and you saw me speaking like this. The other reason was you were working on a project and it wasn't going so well, and your boss complained to Satya or someone, and eventually I flew out and walked in and went, hey, what's up, man? And I told everybody, like, if you ever saw me walk in your office on a project, it was really bad, like, for me to be there. The first thing we always did was get people to turn the diagnostics on. Because you're sitting there going, it doesn't work and I don't know why. And I go, yes, you don't know why because you haven't got any logging or perf counters to look at. So go and turn them on. And then we'll have some coffee and we'll calm down and we'll have a look at what's being generated. So do yourself a favor and turn those darn things on straight away. And you'll get so much insight into what's happening in your application and everything. It will save you oodles and noodles of time. The other thing you can do, and I didn't show you this, is you can enable RDP in those roles. So you can actually RDP into them and load up your favorite debugger and do crash dumps and collections and all sorts of things like that. So you can get at the kind of the meat of it, if you like, as well. Cool. Great. That's where I wanted to be, and I've got 4 minutes. Wow, fantastic. I will stay around for questions and things, but other than that, thank you very much for your time. I hope this has been useful for you. Thank you.